The OSI, or Open System Interconnect model, is used to define a framework for developers to use when creating network-related hardware or software. Without this model, every manufacturer would have their own way of making things network. This would cause compatibility issues and make networking on a large scale impossible. The model is made up of an order of operation. Control starts at layer 7 and is passed down through the rest of the layers. The computer uses this layer to determine what protocol is or will be used to transfer data on the network. For instance, data from an email program will be put into SMTP and then sent to the next layer. Translation is needed in network communications. This is due to the many types of computers, like mainframes, Mac OS, and Unix systems, and the different ways that they communicate. Without translation programs, all the different computers would not be able to communicate with each other. Compression is provided as a means to remove unnecessary bits that otherwise would be transmitted on the network, causing unnecessary network traffic. This layer also provides encryption. Encryption is the scrambling of data that would normally be readable by any node on the network and making it readable to only the two communicating. This layer also provides authentication services, like those necessary for logging onto a website.
The session layer is layer 5 of the 7-layer OSI model of computer networking. The session layer provides the mechanism for opening, closing, and managing a session between end-user application processes, i.e., a semi-permanent dialogue. Communication sessions consist of requests and responses that occur between applications. Session layer services are commonly used in application environments that make use of remote procedure protocols. In computer networking, the transport layer provides end-to-end communication services for applications within a layered architecture of network components and protocols. The transport layer provides convenient services such as connection-oriented data stream support, reliability, flow control, and multiplexing. The most well-known transport protocol is the Transmission Control Protocol, or TCP. It lent its name to the title of the entire Internet Protocol Suite, TCP/IP. It is used for connection-oriented transmissions, whereas the Connectionless User Datagram Protocol, or UDP, is used for simpler messaging transmissions.
The network layer is the third layer in the OSI model. In a real-world experience, it consists of the point of service you have with your ISP. That's the point you take control of the internet with your router. A router is a network layer device. It uses the ARP address resolution protocol that has a table of every node on the internet network. The network layer protocols are a logical IP, which is your address on the network that corresponds to your MAC address.
The data link layer is in charge of providing physical device addressing, delivery of frames from device to device, media access control, and MAC addressing. The PDU is in frames. The physical layer is in charge of managing hardware connections and the handling of sending and receiving binary signals. It is also in charge of handling the encoding of bits. The PDU is in bits.